In this video, we're going to look at membranes and answer the question, why do cells need membranes? So as a review, membranes are made of lipids. These are fats, oils, and waxes, and they don't mix with water. That's going to be real important here. So what is a membrane? Basically, it's a container for a cell, or in some cases, for certain cell parts. Every single cell there is has a membrane. So here's some examples. The white line around the outside, that's a cell membrane. The next picture shows a prokaryote, which has a membrane, and the third picture is a mitochondria, which is a cell part that has its own membrane. So all three of these things have membranes, and the membranes help contain them. So what are cell membranes made out of? Lipids. We've already talked about that. Specifically, phospholipids. Now, membranes are also going to have proteins and carbohydrates in them as well, and these also have specific functions. So a phospholipid is made of two parts. We have a phosphate head that really likes water, and so we call that hydrophilic. Philic means to love, and hydro means water. And then the fatty acid tail that hates water, hydrophobic. So think of phobias. It's like it's afraid of water. So here's my phospholipid. Here's my phosphate head, and that's hydrophilic. And the fatty acid tails, which are hydrophobic. How are they structured? The phospholipids are arranged in a lipid bilayer. Bi meaning two, so two layers of lipids. So this is what your membrane is going to kind of look like. So on the inside and the outside you have the phosphate heads, which remember really like water. And then on the inside you have these rows of the fatty acid tails that hate water. And that's going to be helpful in creating what we want to do for this membrane. Now, the carbohydrates and the proteins are going to be used for communication and transport, because cells need to be able to communicate and they got to be able to move stuff across. The way I think about this is that the carbohydrates are kind of like signs on the outside of a fence. They tell you information about what's inside. And then the proteins are like gates. They allow things to come in and out as necessary. So think of the lipids like the fence, the carbs like the signs, and the proteins like the gates. So how does a membrane work? The phospholipids keep water inside the cell and outside the cell, but not in between. Because remember, the fatty acid tails in between really don't like water. So here's just kind of a cutaway of a cell. We've got water on the inside of that cell, water on the outside, but that membrane keeps those two things of water separate, and that's what's important. So why are they important? Well, number one, they keep cell stuff from just floating away. I mean, think about, like, why is a bowl important? Well, because if you don't have the bowl, your soup ends up all over the table. Same thing with a cell. If you don't have a membrane, how do you really have a cell? Because everything just kind of floats away. And then also, very importantly, they help control what goes in and out of the cell. And this is called being selectively permeable. Permeable means things can go in and out, but you're selective. Only certain things can go in and out. So I kind of think of the cell membrane, it's sort of like a bouncer, where only certain people can come in and out. Or it's like a fence, but you can open the gate in certain cases, but only some people have the keys and that kind of thing. But what's really important is membranes control what goes in and out of that cell. So here's my membrane. Some molecules are really big, and notice it's not going to fit through the gates. We don't want that thing to be able to come in and out. Whereas some molecules are really small, and they're able to pass easily through the membrane. This is what we call it being selectively permeable.